Hello students, this is Dr. Ben. Let's work on another problem out of the last part of Chapter 4 that has to do with projectile motion. So this problem has to do with firing a rifle and measuring some properties of the bullet. And as we set up a projectile motion problem, one of the clues that we need to hone in on is the geometry of the launch. And so in this particular problem, there's a clue right here that the gun is aimed horizontally. And that's a very important observation because that helps us set up the pictorial representation that we're going to use to define the problem. So let's set that pictorial representation up on a coordinate system, x to the right and y pointing upwards. And let's let this point represent the bullet when it leaves the gun. And then we'll tap out the motion, and this bottom point represents the bullet when it hits the ground. And because the rifle is launched horizontally, the velocity of the bullet is completely in the positive x direction in our coordinate system. Alright, let's label this as point 1 and this as point 2 and write down our kinematic variables, x1, y1, v1x, v1y equals 0. Then for point 2, we would need the values of x2 and y2, and then t2 and t1. And then finally on my diagram, I'll indicate that the acceleration in the y direction is the acceleration due to gravity, and that points downwards. Alright, so now that we've got that pictorial representation done, we can make our list of what we know and what we want to find. So the units in this problem are English, and we can clearly change them to metric units, but if we recall that the acceleration due to gravity is 32 feet per second squared, and the fact that 1 foot is equal to 12 inches, I believe that we can do this problem entirely in English units and not have to switch to metric. So to continue this table, we know that the value of y1 is 9 inches, the value of x1 is given to be 0, the value of y2 would be 0, and then the value of x2 would be our 300 feet that we can convert to inches if we need to. And we also know that the velocity in the y direction initially is equal to 0. And what we want to find is the value of v1x. Alright, so we have kinematic equations at our disposal to use in solving this problem, and I think that we're going to need to find the time that it takes for this bullet to fall the known distance, so we can use that to find out the velocity in the x direction. So we would want to use one of the equations that has the position in it, because that's what we know about in the y direction. So if we write down that y2 equals y1 plus v1y delta t plus 1/2 ay delta t squared, then that equation will help us find delta t, because in our problem this term with the initial velocity is equal to 0. Alright, so let's leave our units in inches, and we'll see if we can work through this. So we have y2 equals 0, y1 equals 9 inches, plus the next term, which is 0, plus 1/2 times the acceleration due to gravity, which is minus 32 feet per second squared. Then I'd have to multiply that by 12 in order to get the inches there, times delta t squared. Alright, move my paper up a little bit, and we can solve this expression for our delta t. So I take the 9 to the other side, I get negative 9, and then I multiply by 2, divide by negative 32 times 12, and that will equal delta t squared. And so delta t will be the square root of these numbers, 9 times 2 divided by 32 times 12. So if we get our calculator out and we work through that, we have 9 times 2 is 18 divided by 32 divided by 12. And then we'll take the square root of that number, and that gives me 0.216 seconds. 0.216 seconds. So that's how long it takes this bullet to fall the 9 inches of travel. And now the x direction is straightforward to deal with, because in projectile motion, the x direction, there is simply uniform motion. So in the x direction, we can simply say that delta x is equal to the velocity in the x direction multiplied by delta t. So therefore, v1x is going to equal delta x divided by delta t. So that's going to be our 300 feet divided by our 0.216 seconds. Move my paper up a little bit. Times 300 equals 1,386. 1,386 feet per second. So that's probably too many significant digits in this problem, so maybe we should round it just to 2. So we'll keep that as 1,400 feet per second. And that is a very large velocity, but it's a reasonable muzzle velocity for a bullet. And just to finish this problem, we'll check that we have our units. We weren't told what system to use, but we do have speed measured in distance per time. We have our significant figures. We actually eliminated a couple. We probably had too many in the problem.